Okay, everybody, thank you for coming out to see me. I'm going to be talking about unmanned systems flight planning in Clojure. My name is Heow Goodman, and I work for ATA. I'm a full stack engineer. We deal with a lot of different problems, and so might you. So if you're out flying your balloon, the last thing in the world you want to do is end up like this. So, turns out this is a very interesting problem. It's not just relating to balloons. So, if you have a drone and you decide, I'm going to go out and fly it a bit, there could be a lot of things you're dealing with, a lot of different hazards. In this case, we're looking at a radio station or high frequency anything. You could be in the way of oncoming aircraft, known or unknown. If you're in Ohio, there could be another train derailment and hazardous chemicals, anything you like. And in this case, the king could come and visit. Now, if you're wondering how you should go about finding out whether or not you want to fly your drone, you also have the issues of whether or not you're dealing with federal or local laws. And federal is anything in the air, and local is basically everything in the ground. This is, of course, simplified. To make matters worse, there are even more rules depending on how high you want to fly your drone. So 400 feet above, it's a completely different ball game. And then, of course, there are lots and lots of rules, depending on what you're flying, where you're flying, and what you decide to do. So you definitely don't want to be in the way of the cops, the radio cops, the train cops, the cop cops, or the bobbies. So, this is where we use software. So this is an interesting problem because you're looking at an X, Y, and Z axis, on a globe, plus time. And you're combining different data sources from different local governments, different GIS systems, as well as FAA UAS systems. So we're making some software called Airdex Authority. And this software aims to solve this issue right here. So it administers, collects, and disseminates this information. This is designed for state and local governments, by the way. I'm not trying to sell this to you. Particularly, this is about public safety and emergency services. On top of that, this is a 100% Clojure and ClojureScript development. We're running on a Kubernetes stack, and everything that we have is Clojure and ClojureScript, including all the utilities. So it is a very unique system in that case. Now, the political and technical landscape that we're looking in, also, Airdex is what we're talking about. But we have a lot of different entities that we talk to. State transportation boards, local public safety, your local government, emergency services, other UAS suppliers, and of course, people who fly drones, both public and commercial. Private and commercial. So let me show you a little about what we got going on. So if you're a state official, you can go ahead and create an advisory. Now, we are here in Durham, and this is the convention center that we're looking at. So we're going to go ahead and create an advisory. So if I'm a local official, I can go ahead and do this. So we're going to create a quick advisory. Now, at this point, there's quick advisories and there's also advisories. I'm not going to make you watch me type in the long form, so we're just going to deal with quick advisories here. And when we do this, we can set up the safety type. This is going to be a large audience event, so everybody here, we are a large audience. This level here, the security level, is who is going to be able to see this. Is this information restricted, or is this sensitive, or is this unrestricted? And this involves who is going to be able to see this disseminated information. This is so that baddies are not going to give a listing of places they want to do terrible things to. And so this is auto-populates all the time, and of course we put in a contact number. Everything's auto-populated except for that. Of course, this is for Rich Hickey's security detail, so we're going to type that out too. Now this works a lot like Google Maps. We're going to say no flyovers. And what we do is we check for collisions with other advisories just to make sure that everything is on the up and up here. And once it's in, our advisory is live. And while we're making advisories, we can also search for existing advisories as well as things in the map. So again, this works just like Google Maps. So you can type in, a known thing, like for instance, the airport. And as this zooms out, you'll see the little numbers here going from 400 down to 0. This is the Raleigh-Durham Airport, and they don't want people flying around. So they're giving flight ceilings here. And it's set up like an inverted pyramid. So that planes coming and landing, you can fly your drone to different heights, including 0 when you're close to the airport. And you see our advisory that we created over there. And the advisory types we have are all set up for different agencies. So you can have all these different types here, depending if you are emergency services or police, or there's a derailment or whatnot. As well as the restriction level. And I forgot to mention, you can also search for old advisories. The existing ones, as well as old ones made by you or other people, which is real handy. So this is a very robust database. And you can display them and hide them and whatnot. Yes? Those altitude numbers are the flight ceiling. So, in feet, yes. The laws are made in feet here in America, and so everything is reflected in feet. And for instance, it is 400 feet above, in which you do not need permission in order to fly, essentially. Now, when you're creating advisories, you can do this in any shape. So for instance, we're going to make a circle. It might be a little hard to see the light. You can move it around, you can make it bigger, you can make it smaller. Go for a square. You can also modify them all. So we're morphing the square into another shape. Or in this case, we can go ahead and do the entire inner belt here as a random polygon. So this integrates with the other pieces of software. It's not just us. So Airdex Authority, which I've been showing you, is here on the left. And Beeline, which is consumer-oriented, is showing on the right. We also make Beeline, but that's not what we're focused on today. This data is also sent to applications on your phone. This is for a loft, so you see the same information here. So if you're a state official or emergency services, you can go ahead and set them up. And if you're a user, you can see everything in Beeline here and see the different advisory types. So if I go ahead and delete it, as we see here, in just a minute, it will go ahead and delete from the Beeline system. So while we're doing that, there we go. We're going to set up another one to go the opposite direction. So before we had a circle, and then we went ahead and deleted that advisory, and then we went ahead and made a square. Now, this is not instantaneous. As a matter of fact, a loft, I think, only pulls from us every 24 hours. So, depending on which system you're using, it depends on what you're going to be seeing. I'm not going to force you to watch 30 seconds of nothing. Come on. There we go. Now, on top of that, I mentioned the collisions. As long as your advisories are not colliding with other advisories, you can also stack them. So, or your this could also be a listing of advisories that do not collide over time and space. So in order for a collision to be detected, they have to be other people in time and space, and then you're not going to be able to set it up. That's what the collision detection was for when we had initially created it. But you can stack them, you can have them at different dates, you can have them essentially move over time as you're going through this. So that's super useful. And there's nothing stopping your advisory also from going into the airspace of the airport, for instance. That's just more reasons to not fly your drone, essentially. On top of that, there is an entire administration suite in here. So we can set up all of your different agencies, and this can be state and local governments, this can be emergency services, police, et cetera. These are different users you can set up, again, with different agencies, et cetera. And all the advisory types. You see some of them are disabled, some of them are enabled, but you can go ahead and create specific ones for your location, locality, et cetera. And of course, there are reports and reports. This will make the suits super happy. So, does this really matter? Is this anything more than a business app? I mean, seriously. Because, if you could do this under 250,000 lines of Java, I'd like to see that. And matter of fact, I doubt you could do that just with the swing section. But we're doing this in Clojure, and the entire system is 250,000. 25,000. That's Clojure and ClojureScript combined. This is also our test suite. This is all of our tools. This is all of our utilities. We have an entire Kubernetes cluster running this with microservices. And just for funsies, I looked it up, and 25,000 lines is smaller than the leading Java logging library. So you get all of that I showed you with just that. Part of the magic that we're doing it is that we're using shared Polylith bases and components that she just talked about in the previous one. We're also using reagent and reframe, which I'll get into in a minute. Additionally, this has allowed us to pivot. We've had to pivot a lot in this project. Until it calmed down, we were pivoting every 6 months for the first 5 years. And Clojure really allowed us the crazy flexibility that we needed. And because of that, I think this is one of the reasons we ended up in the situation where we are with highly reusable components, because we're having to change every 6 months for at least the first 5 years. And this is something to keep in mind, because Clojure really allows you to outrun your competition. I have many experiences of completely finishing my Clojure app before the documentation of the write-up was even done for the other team of their RFP or whatever. So I mentioned this is running in Kubernetes. So we do have an entire cluster of microservices running. Just about everything is running in Clojure. We have some Babashka running in order to set things up. But all the pods, everything is running in Clojure. And it is non-trivial. We have, let's go back. We have 4 main services, so we have at least one pod for each one of those, plus 5 or 6 secondary and tertiary services, and those are all running at the same time. We have multiple databases and a messaging system, et cetera. So, all of that in 25,000 lines of code. We're also running reagent and reframe. This is the magic that you saw before. Reagent we're using for the views, the rendering, and the state. All the state is stored in reagent in the AppDB. Whereas reframe turned out to be really well for event subscription, and all of the logic is used in reframe rather than reagent. Some of the issues we ran into is ClojureScript can get complicated when you're separating the builds. We have a single page app like we had, whereas the back end that we saw with the users and the administration and stuff, that's more of a web app. And it's hard but not impossible to get the code reuse over that. Some of the reframe and React errors and stack traces can be hard to grok if you've ever looked at that. You're just squinting a lot. And of course, Figwheel could be used a little better. But, however, some of the things we ran across that are really good is that reagent allowed us to run once and write it once and run anywhere in our code base. That was super, super useful. It allowed us to do quick, simple, consistent, and clean code. That was right. And just the right amount of structure for what we're doing. And of course, you have the full power of Clojure. You're not stuck in some dumb little language. You have your code is data, you have higher order functions, you have everything, almost everything that Clojure has to offer, which is what I really like. You don't really have to compromise with that. And what you saw here is not just one GUI, we actually have 3 of them. I alluded to the SPA plus the regular web app, but we actually have 3 of them. And the code base kind of reflects that. I'll show you in a second. So we're using Polylith. And in the previous presentation, she was talking about how Polylith allows composable blocks of code, essentially. So we have 4 main projects that are running, and 2 Clojure bases, which are the base units in the base code set of everything that we're using, and then a lot of ClojureScript components. 87% of all the Clojure code is shared inside of Polylith bases, which is super cool. And of course, the blocks are simple, stateless, and you try to make them pure of side effects, and really allows you to put them together. This is the Polylith way of displaying things. So the base is blue, the component is green, and the library is gray at this point. So on top of the 25,000 lines of code includes not just our microservices, but also the APIs that are also running in microservices. And those are just a base and a component. Whereas the user UI is 2 components, 1 library, and a base. And the same thing with administration and public UI. Those are nearly identical, but with different bases. So this is what allows us to use the serious code reuse here. And also we're using Babashka. So one of the development patterns that she was talking about is using a mono repo, and that's what we do here. So we have a single repo, and then we use Babashka in order to do all of our builds. So Babashka takes a look at the images that we need and sets them up with scans and tests, figures out the dependency, the ordering, all of that, and super, super fast. We use it for a lot of DevOps, and it's come in very, very good for that. And this turns out to be a non-trivial problem, and it solved it perfectly. It really did, without even needing to make a DSL, just a really nice data structure. So using Clojure and ClojureScript, we're allowing to do drone advisories. And what we're doing really is data as a public service. We are not tying all this behind a paywall or anything like this. We're really looking at this as getting the data out, because it's no use to us stuffed in a database that nobody's going to look at. All the data is shared with other providers, and it's also integrated with the FAA. And again, all of that code is still in that same 25,000 line of code base. Everything, absolutely everything. So with this really allowed us to outrun our competition seriously. With just 25,000 lines of code, reframe reagent, Polylith, and Babashka. So ATA, we are hiring, actually. We are a Clojure-first company. You can work from anywhere. We like to work on interesting problems, and the work we do, we like to feel is meaningful. As I mentioned, we're doing data as a public service, and we're really looking at improving public safety. And part of the reason to work with us is that we make it easy to work in industries that are hard to break into, like NASA and the FAA and aircraft manufacturers. It's really fun working with them. And of course, we do modern DevOps. So we're doing Kubernetes, pair programming, mob programming, and actual real Agile, not just, Agile, on a business card. And that's it. Have any questions?